Hello, my name's Marty Mulvihill, and I'm the Executive Director for the Berkeley Center for Green Chemistry. Green chemistry is an approach to making materials, chemicals, and processes as efficient and as safe as possible. If you think about it, it relates to a number of the other global sustainability challenges and approaches. So something like the circular economy, where you want to reuse a material at the end of its life cycle, you need to make sure that whatever the chemicals are that go into that material, that they're safe so that they can be easily reclaimed, used again, and don't create harm to human health or the environment as they're used. You also want to make sure that however you're making those materials, you're making them as efficiently as possible. So it relates to a lot of the sustainability drive to reduce water use or energy use as well. What makes green chemistry unique is that it focuses on the molecule. It takes a molecular level approach to designing things that are inherently safer and better for human health and the environment. So green chemistry is different from traditional chemistry insofar that the chemist at the bench is actually thinking about what is the best starting place for making a particular material. So they think about feedstocks. Can I use something that's renewable? Can I use something that's inherently safe? Then, when they're running the reaction, they're thinking about how do I make it as efficient as possible and do things so that I don't produce any additional waste. I do it in the fewest number of steps. And the things that they're trying to make, the products of the chemical reactions, are things that are benign, things that are going to be, and also things that will break down at their end of life or be able to be reclaimed. So at the bench, the chemist is specifically thinking about these design parameters so that they make things as safely and as efficiently as possible. Traditional chemistry has a lot to offer. A lot of the tools that the green chemist used were first derived from traditional chemistry processes. What distinguishes green chemistry is really the fact that we're trying to optimize for safety and efficiency throughout the process. When we think about making something that's safer, what we're talking about is the fact that any molecule, no matter what type of molecule it is, from the moment it's created throughout its entire use, it has the potential to interact with both humans and the environment. We want to make sure that those interactions are benign, that they don't cause harm to human health or the environment. Now, nothing is completely benign. Everything has some risk or hazard associated with it. So the reason why I say safer instead of safe is that green chemistry is part of a continual improvement process. We take a look at how things are done today, and then we go back to the lab and we figure out how they can be done better to encourage human health and environmental health. There are a number of examples of things that have been made possible by green chemistry. Historically, a lot of the work has been done on improving the efficiency and reducing waste associated with industrial manufacturing. In our own lab, something that's been made possible by green chemistry is the creation of a circular economy type product where we're starting with a waste material, in this case waste cellulose, cardboard, paper, things like that, and we're forming it into something that looks like this. So this is a board that could be used in buildings, either as part of a roofing material or indoors, and it's made from nothing but waste cellulose. The first time that someone did this, the way that they held it together was using things that relied on potentially harmful chemicals, on formaldehyde. Now what we're using are starch derivatives. So starch is inherently safe, is edible, and is now what holds this together. In addition, if you want to protect it from water, you need to coat it with something. And the original coatings that were used were things that had epoxy resins or perfluorinated resins that were potentially harmful. Using green chemistry and benign additives, we're now able to use things like latex paints, which are a lot safer in order to coat them to make them waterproof. There are a number of benefits to using green chemistry. For example, in our building materials projects, one of the key benefits to using all safe and bio-based materials in producing this composite is that it means at the end of life, you could actually compost it or put it back into the environment in a safe and sustainable way. You wouldn't worry about the same sort of effects that putting something that had a lot of harmful chemicals into the environment would have. So it's better from a life cycle perspective. It's also better for the occupants of the building. So by removing formaldehyde and other toxic chemicals, we're making it a lot safer to be inside the built environment, inside the space. So while there's a ton for chemists to do in the lab to create new materials, there's also a lot that can be done if you're not a chemist to help people adopt safer and more sustainable materials. In a lot of cases, just understanding the chemistry behind a material or process that you're using can inform the selection of safer chemicals. So non-chemists, whether they're designing a manufacturing process, consumers, or people that are interested in the regulation of materials, they can just ask the question, what chemicals are in here and are they safe? Are they something that I want to bring into my home, that I want to share with my family? And by asking that question, you're going to put pressure on the folks that are producing materials to choose the safest and most sustainable materials possible. Yes, yes. This is Roshan. She is my daughter, and she is one of the reasons why I do green chemistry. One of the things that I like to tell people is if they want to be involved in green chemistry, they should just ask the question, is this something that I would want to bring home and share with my family? And if the answer is no, maybe you shouldn't put that in your beaker. Right, Roshan? Yeah. If she can't put it in her mouth, you shouldn't put it in your beaker.